Hi, my name is Jessica Bryant, and today I will be talking about the science behind the 601 Lexington building. This is the 601 Lexington, originally known as the Citicorp or Citigroup Center. It is located in New York City and was built to hold the headquarters of Citibank. This building was created in 1977, and upon looking at it, the 915-foot structure does not look stable. At one point, this was the case. 601 Lexington, a very tall skyscraper in New York City, was built with one of the biggest architectural design flaws in history. Today, I will first explain the history of this building and its design. Second, I will present what solutions were used to keep the building strong. Third, I will explain more about the science behind these solutions that were used. 601 Lexington was built with one of the largest design flaws in history. First off, it was built around and above a small building, the St. Peter's Lutheran Church. There was a deal that it could be built there as long as the architects did not interfere with the corner of property the church was built on. Next, the main structural engineer realized that some of the materials that were used to build were not the best quality. This would mean that the building would not be able to withstand 70-mile-per-hour winds. Lastly, a college student noticed that even if we were able to upgrade the materials, the building would still not be completely safe in all wind conditions. Though there was a lot wrong with this building, the main engineer was able to find some solutions. First, to avoid the church on the ground, stilts were placed in the center of the four sides of the building's base. This and a chevron or V-shaped bracing system helped to stabilize the building. Next, 200 bolted joints in the building were reinforced with a newer steel. Lastly, the real physics exists within the fact that it was one of the first buildings in America to use a tuned mass damper to help counteract winds. The science behind the wind damping system used by the architects and engineers for this building can be seen in other places as well. Why do we need a tuned mass damper, you might ask? Well, we know that force equals mass times acceleration, and acceleration equals force divided by mass. Therefore, if there is a force, such as wind, there will be acceleration. In the case of a building or a skyscraper, occupants could feel acceleration caused by wind. This could also be dangerous to the structural integrity of the building. How does a tuned mass damper work? Most systems use a spring, a mass, and a damping device. The spring pushes the mass, which changes the center of gravity to counteract any winds that push against the building, keeping horizontal displacement as close to zero as possible, which also means that the building remains stable. 601 Lexington uses hydraulics, as a spring, to push a 400-ton block of concrete, which acts as a mass, across the top of the building. Where else is a tuned mass damper used? One of the most famous examples is Taipei 101. Taipei 101 uses a huge pendulum made of a 660-ton steel sphere that is suspended by 8 strong cables. Now that we have explored the topic, let us recap the main points. First, 601 Lexington was one of the most flawed buildings in history. Next, engineers and architects were able to find some solutions to these flaws. Lastly, the tuned mass damper was a scientific solution to one of the building's many problems. This building was an ambitious project, and in the end, the building was made as secure as possible with the help of some science.